Hello everyone, and welcome to the
Hello,
live
hello.
stream.
Yep. I think this is the first live stream in November, right?
It's what is it? It's like 6th of November. Yeah,
Yeah, it's
that
6.
makes
So
sense.
yeah, this is the first one. So for the old listeners, it's not a great weather in Poland. I mean, it's this time of the year when you basically have trouble to stand up early and well, basically you work during the day and then when you leave the work, it's already dark. So that's probably why you don't see anything
Yeah, it's hard to see
outside
the
my
weather
window.
because it's dark.
Yeah. So basically, forgive us if we will be today a little bit maybe hmm, slower
No,
or
we
maybe
we
under the
can't be
weather.
slower. This is a fast live stream. This is live streaming, speedy commentary on React and React Native, as always, as every week. Don't be a bummer, Shimon. Just like energize yourself. Look, Jig didn't pay. Jig didn't pay me for this promotion, but I'm drinking a caffeinated drink. Hello, Ryan. Good to see everyone. Maybe we can play a little game at the start. So maybe you can,
Hmm.
listeners, viewers, you can tell us where are you watching and what's kind of weather is outside your window. Ryan, you can start. And while Ryan is typing in the comments, maybe we can introduce this live stream. So this is a weekly live stream from Callstack. My name is Łukasz Chludziński. I'm a host of this live stream. Today with me is Szymon Chmal, my beautiful guest, very energetic, very smiling, as always. Hello, Szymon. How are you?
Hello, hello. I'm fine. I'm after my session, after my gym session, so everything is basically stiff and I feel awful. I mean, my muscles feel awful, but yeah, I will try to be as much energetic as I can.
Nice, nice. You
So
have to you have to fill in for Kevin. So Kevin is not with us this week. Uh but we do have a huge subject for you. So, like usually on this live stream, what we do is we go over React and React Native news from this week in React newsletter and we comment on it, we play around with some things. This week might be a little bit different. We'll spend much more time on our main topic, which is Hermes V1. And to discuss that, we have a guest. We have Matt Hargett, who has been on this show before. Back in March, I think we discussed links together
yep,
with him.
I was there. Yeah.
Yeah. So today he's joining. He will join as well. Hopefully sometime soon. So while we wait for him, we can go over some of the news and some of the newsletters and etc etc. So yeah, let's jump into it. So this is the screen share and this is my screen, I hope. Yep, that's the screen. And as always, this week in React has a newsletter. This time was prepared by Sebastian and Armand. Huh. Armand, I haven't see your face in this newsletter, so I'm not sure if he's new or maybe he's not that often contributing to this. Usually is either Sebastian or people from Software Mansion.
Yeah, I'm waiting to see your face on the
As
newsletter,
a
but
curator of news for This Week in
yeah,
React,
sure. Why
oh
not?
man.
I mean, you are part of your job is to be up to date with whatever is going on in the ecosystem. So why not?
This is part of my job, and this is the favorite part of my job. And do you know how I do it? I read this newsletter every week on live
I know,
stream.
but for once you could maybe do something to make this newsletter better, or maybe not better, but to make this newsletter for a given week. Not only taking from it, but also contributing to it.
I have so much. This is a hard work, and that's why I have so much respect for Sebastian, who has been doing this for 257 editions.
Weeks.
Not all of them are like curated by him personally, but like this is such a such monumental work that they are doing on newsletter. And also like I have such a huge respect for Armand here and for people from Software Mansion that are contributing to this as well. It's hard. Like I can't imagine like the amount of work that goes into curating this newsletter, because like there's so much going on every week.
I kind of feel if you follow the right people on X, for example, or LinkedIn,
Mm-hmm.
then your job is basically to be up to date with whatever comes on your board.
Yeah, I
Because
guess
there are
so.
so
And
many
like,
like people reposting the same thing over and over again. If it becomes hyped for some reason, that sometimes, or even not sometimes, but usually I see things popping up on my X board, and then I see them in the newsletter. So I
I'm not
guess
sure.
Sebastian has a super nice, let's say, contact list or observation list or whatever we call it on X. So he's basically up to
Yeah,
date
I'm
with
not sure
whatever comes.
how to get there, but like because like this X account is my X account only for this live stream. So usually like at the top here, you would have like the lists of the how do you call it, feeds that you can choose from,
Mhm.
and I have this Week in React Twitter feed as well in my personal account.
Okie
Okay.
dokie.
Oh,
So,
let's jump into it. So, this week we found various interesting React releases and leaks about directives, partial pre-rendering, performance microfrontends, I18N, so internationalization,
yep,
among other things. On the React Native side, we have two major releases and various interesting weak signals. Weak signals? What's that?
don't know. We will see.
Probably the attack, the vulnerability in
This is
CLI.
the next sentence. If
Be aware
you
of,
continue,
yeah, vulner. How do you, how do
I
you read
won't even try. This is one of the words I cannot really pronounce. My tongue is
vulnerability?
basically stuck
Okay.
in the middle. So, uh, security problem, security issue. That's the better word for that.
Okay,
Uh,
let's jump into it. Navigation API available in all browser stores. The exciting new web platform API will soon be available in all browsers. Windows fine. Instead of using the awkward history API and having a
uh,
link.
yeah. So the history on web is that if you want to navigate, you need to use anchor element, right? The A element with href attribute.
Mm-hmm.
So how it's implemented under the hood is basically there's a listener stopping the native navigation and then triggering some JavaScript logic to basically display a different screen or page, like virtually using with the use of JavaScript and React. And now they will be a centralized place. You can basically listen for all navigation events and make side effects from them, basically.
But this is not new, right? Like the navigation dot. It's not a
Um,
new API.
I'm not sure, but if you go down, like, yeah, the can I use? I think that's the name of the library of the pages. So the one with versions. So it was implemented in Chrome in 102, and now the question is when 102 was released. So let me quickly. Oh, it was 3 years ago.
Yeah.
Okay, so it's not definitely not a like brand new thing. But the problem with web specification and all the APIs on web is that every browser has different pace when it comes to incorporating new APIs into their browsers.
Mm-hmm.
So, for example, Chrome is super fast, and they usually create APIs and, for example, backport them to web specification. Uh, but technically, yeah, Chrome is very fast with that. Safari is sometimes fast, sometimes slow, and Firefox again it depends. But if you want to incorporate something like this, like navigation API in all the browsers in basically in React, for example, which can be run on all browsers, you need to wait for all browsers to implement the API first. That's usually how we do it, because in some cases there is no way to provide the same level of experience with some polyfills, for example. So that's probably why it took 3 years for this API to basically start being used in, for example, React.
So basically, this news is about not a new web platform API, but that the navigation API will be available on all browsers, basically.
So in terms of web platform, it will enter the, I think it's, what was the name? Because they created something called baseline. So if you want to go, if you go to MDN and you will find the navigation API, you will also find the baseline tag. And baseline says if it's newly available, and then I think widely available is the second level, or maybe this is okay. So maybe they don't consider it a part of baseline yet, because if you search for baseline, you will find a website with all the APIs that are considered stable to be used in all browsers.
Okay.
So for some reason, this one is missing.
I'm not sure though, like where is this coming from, right? Like where is? Okay, from this.
This is Can I Use. This page is called caniuse.com.
Caniuse.com.
My most favorite page when I was a web developer a couple of years ago.
Navigation
API. I think you need to add the second one.
API. This one. Okay.
Yep. And the baseline is basically limited availability because it's not available yet in all the browsers, but it will switch at some point to widely available.
But like, so it means that Safari is not supporting this. Firefox is not supporting this.
Yet.
Okay.
But I guess there are some traces of changes in the source code of both Safari and Firefox saying they are going to implement it soon.
Okay. I think we can move on. One side note from me, I love coming to this live stream with you because you know a bunch of things that I don't know, and this live stream is specifically for me to learn about new things. So thank you so much. And Ryan says that he's from Madagascar. I feel that you already told us that few weeks ago, and it's cool tonight. Oh, sorry for that.
Maybe it's good. You know,
cool.
It depends how warm is the day.
So what else can we? You know what? Let's jump into React Native. Let's talk about. Oh, this one is cool. This one is actually cool. And I have a question. I'm not sure if you know this. I don't.
Know.
So we have Matt. Hey Matt, how are you, man?
I'm doing well. They're doing some work here in the street, so my internet was down for the last 30 minutes or so, but now it appears to be back.
No worries. We started without you, as you can see.
Sorry.
And right now we are in the portion of the live stream when we go through like React and React Native news, and we just like play around with some stuff. But our main topic for today is Hermes V1. So how about we jump into it?
Yeah, it's high time. I mean, this is the main topic, so we're just playing on time to
So actually, like Hermes V1 was announced with React Native 082 on ReactConf. Oh, when was it? A month ago already. And what else? It's like it is confusing for me because Hermes V1 doesn't mean static Hermes. It means something else. So we can talk about that. But also, Matt, I know that you have a bunch of like different topics around JavaScript engines and around Hermes. So maybe let's start with your thoughts about them releasing that a month ago and what happened since then. Like, what's the community reaction, adoption, etc.
Yeah. So my first exposure to Hermes was the team at then Facebook was kind enough to invite me to the repo before Hermes was open sourced. At the time, I
Like
was a
5
principal.
years ago? No, more than that.
It was in 2019 or yeah, I think it might have been early 2019. The repo was not public. And fun fact, for the initial public release, they actually squashed all the commits in the repo up to that point before they released it to public. So it was a little even more educational to kind of look at the commit by commit then. But I was a principal engineer at PlayStation at the time, and there's some very aggressive performance goals around the PlayStation 5 applications in terms of their startup time to make it a really magical experience. And Hermes seemed to like really fit the bill there in terms of just being bytecode first, doing the text parsing and bytecode compilation on the client side doesn't make a lot of sense at all.
Sorry, so
Like,
was it like bytecode enabled from the beginning? I thought that was
oh yeah.
some like additional feature that they added later.
No, I mean maybe in their internal history it started in some other way, but the way it was portrayed to me was this is a bytecode execution first VM. So all
Okay.
the stuff about making the lexing fast, so it happens in real time on the client or whatever, it was not optimized for that at all. And what it reminded me of at the time was when Microsoft first released .NET, and everyone at the time in 2001 or yeah, about 2000, 2001 said, oh, it's just a clone of Java at the time. But the .NET, the common IL, intermediate language CIL, was designed and optimized to be JITted. Whereas Java was meant to be interpreted because in the mid 90s, doing JIT compilation on the client was also not practical with 4 megabytes of RAM or whatever. And so this Hermes approach of taking a fundamental precept a lot of the other virtual machines have been developed against and turning it upside down was really exciting. But also for the app startup time to not have to include the lexing and the parsing was really exciting. And we had gotten a sort of a preview of this at Blue Jeans, where I worked, when we used Chakra Core in React Native Windows. And Chakra Core also supported, which was a Microsoft JavaScript VM, supported bytecode bundles. And so for the Blue Jeans app, I already knew that going from text bundles to bytecode bundles on lower end laptops that were very common in Blue Jeans' enterprise customers at the time, you could shave like a second or two sometimes off of the initial kind of application time to interactive time on those lower end laptops. And that's a better user experience. And that was like the whole goal. So yeah, so my kind of history with Hermes as a developer integrator started back before even the sort of public release. And so I ported that to the product that became known as PlayStation 5, everything except the debugger, and did a bunch of benchmarking on the dev kits that we had at the time to show that it was, at that time, unequivocally faster in terms of app startup time, getting like time to interactive times down. It was unequivocally faster than the JavaScript core runtime that we were using on the system at the time. Once you're in the app and start doing things, the performance was not quite as clear cut, but definitely the startup time was a huge leap forward at that time.
Okay. And this is because we don't have to like get all of that JavaScript and like interpret it on the fly while your app is starting. It's because you have this like pre-compiled bytecode kind of bundle that is optimized somehow.
I mean, it was still interpreted, but like the amount of time you need to spend on interpreting things will be way, way slower.
Right.
Okay.
There's a high level phrase which was like M mapping. M map is a Unix system call. M mapping the bytecode file into memory and immediately starting to execute. The interpreter immediately starts to execute. So in sort of progressive loading and all this other stuff, you don't even need to do that. And these sound small, but all these little small things like lexing and parsing and then bytecode compiling or whatever, it all really adds up to something that the user, not the developer, the user of the application can feel, where they can articulate what doesn't feel right or what feels slow or not. And sometimes that feeling slow versus feeling fast is a few dozen milliseconds. Especially when it comes to app startup times. Like it can be a very thin margin that makes a huge difference in terms of how it feels to the user.
Yeah, I think that was
this. I will add a thing there. The problem was also that if your app grows, if your bundle grows, the parsing time will also grow. So the bigger your app is, the longer user will wait for it to launch. With bytecode, it's not that like
linear.
the multiplier is exactly, like multiplier is really low.
Yeah, and we jumped through so many hoops. We in the general community, JavaScript sort of application community, jumped through so many hoops of how do we split the bundle. We had indexed unbundles, we had RAM bundles, we tried all these different kinds of ways to sort of, again, like as the application grew, not to have to read in one giant 15 megabyte JavaScript text file all at once before anything could happen in the whole app. So there's a lot of really cool innovation and neat ideas back then. And shout out to Eric Rosell who was at Microsoft at the time and has been at Meta for a few years now, who went really deep on that stuff to just figure out how do we, write in JavaScript and share JavaScript code with web for our native apps, but how to make those native apps, the app load times feel like native apps. So there's a blog post of his that's still up about index unbundles, I think is what he called them, to try to work around this problem. And bytecode bundles dramatically reduces the need for a bundling system that is so complex. You need a principal engineer dedicated just to the bundling system, keeping it working. Module federation helps with this to some degree and commoditizes that to some degree, but even that's not a total silver bullet for app launch times being performant across lots of devices. And so there's with Hermes and module federation, these things, all these tools are a lot more commoditized than they were in 2016 when we were using Chakra Core bytecode bundles and using indexed unbundles with the React Native rollout that I was leading at Blue Jeans.
So over the past 5 years, I guess, like we went from Hermes being this like new thing, experimental, to being the de facto standard on React for React Native development. For those reasons of like fast app startup, and it was created for React Native, right? Like it was created at Meta specifically for React Native applications. So fast forward, and we have the experimental Hermes V1. So we have first stable. it's such a funny thing to say. First stable experimental version. I get so sorry. Maybe that's not a correct phrasing, right? Because V1 doesn't have to be like the first stable version. We've had stable Hermes for a while.
I think that I think that version numbers can be marketing numbers sometimes. For me, with React Native in general, when it was like, especially in the early days in 2015, 2016, even 20, maybe even now, the biggest sort of proof point wasn't like, it's like, oh, it's at version 0.8 or 0.15 or whatever. It was like, this is already shipping to 500 million people globally right now, and they've got crash reporting turned on. So the feedback loops exist, and the scale exists where this is probably very good, regardless of what the version number is. Because you can make a version number anything, but when you go look at the Hermes Git repo and you look at what versions are tagged, it's 0.14 right now. They didn't tag a V1.0.0.
Oh, really?
Yeah. So.
Oh, yeah.
Which is fine.
Well, the latest release on the Facebook repo is 013 for RN 075X.
Yeah.
From more than a year ago.
Yeah, and if you go to Maven, so what they in the sort of GitHub YAML here, they're to do my benchmarking last night, I had to build it myself because their deployment to Maven, if you go under workflows, and then there's an Android workflow that publishes to Maven, which is cool because you can just, for Android anyway, you can just get an AAR file that has everything that you need. So if you go to maven.org and search for Hermes, it'll come up. And that's at 0.14. So the coordination between what GitHub releases says versus what they tagged versus what they've published into the package managers is a little not quite lined up yet, but they just did it 3 days ago, I think.
Which one would it be? How do I search for it to?
If you search for Hermes, you'll see the one that's JavaScript, and then sort by date in the upper right instead of best match, which is nonsense.
Hermes Android.
Yeah.
Okay.
Best match. Here's a Maven package from 15 years ago that nobody uses. That's the best match.
Well, no, that would be this, right? The com .facebook .hermes, not the com into it.
Correct. Yeah. It's the Facebook one. Yeah.
Yeah. Okay.
And there you go. And that's 0.14 published 3 days ago. Sorry, I've got to maximize my thing here to see. Yeah. And I did download that AAR. I still have to build it myself because it is just the libraries. It's not, there's 2 command line tools. One is Hermes C, which is the compiler that takes in the JavaScript text and emits Hermes bytecode .hbc files. And then there's the Hermes runtime itself, which is a separate binary. And they don't include those in the AAR. So I actually filed an issue in the Hermes repo for them to please include those in the AAR. Because then I could have just just pushed those to an Android device and use those to run my benchmarks instead of having to rebuild it from scratch myself. We'll get to
benchmark soon because like that's our main topic actually. So for everyone listening, you can expect us doing the benchmark and like showing you what is the actual difference on speed between Hermes V1 and some other JS engines. But going back to this post, this is confusing for me for one additional reason as well. They don't really explain in this blog post, not as well as on the stage on ReactConf, what it actually means, like what it means, this V1 thing. Yeah. So I guess the best explanation that I know, and correct me if I'm wrong, they've added a bunch of new JS functionalities like ES classes and like maps and sets. So when they said on stage that Hermes now can you can now use sets and maps, like those new JavaScript functionalities in Hermes, I was like, what? Like I've been using them for a decade or something.
New to Hermes.
But they are new to Hermes, and you don't have to polyfill those like language features. You can just use them directly.
You know,
which is nice. It's nice.
Yeah, the less polyfills we use, technically, the faster the app will be. Because obviously you can optimize things at the native level, which you cannot do at JavaScript level because you are constrained to basically a single thread, for example. Plus, the apps themselves will be smaller because they will not include polyfills, which is great.
Yeah.
that.
So is this the only thing that determines Hermes V1 from the previous version of Hermes, or is there something else?
If you switch the page to the one I shared on the chat,
To the one you shared on the chat.
Yep.
Yeah.
It's
Okay.
exposed from Svetan from Hermes team, basically explaining what the V1 is, and in fact it is static Hermes, but with static part turned off, basically. So it brings a lot of improvements, but the idea
What a
is
clear
still,
explanation.
well,
I know what you're saying. I know what you're saying. The story there is that they've been working on improving Hermes on that static Hermes branch. They are still not ready to release static Hermes, but at the same time, they've done a bunch of other improvements on that branch that they feel they should just release to community instead of keeping it on that separate branch that, like, God knows when they are gonna publish static Hermes. So just like have all of the other improvements that we've done.
My personal guess is basically they started thinking about static Hermes. They realized there are many changes needed in the existing code base, so they started making those changes, and then they realized the static Hermes is not ready and will be not ready in the foreseeable future. So now they're porting it back to, let's say, main.
Yeah.
And releasing V1 without static. So we won't end up in the situation when the, let's say, Hermes 0.x is technically not developed for months or years while they're working on static Hermes, because we don't need static Hermes to gain from to gain from other changes included in this branch. So, for example, we can see, let const async, I guess.
Yeah, so
async await
better support
classes.
for modern language, better interpreter performance, speed ups in library functions, no more limit on number of properties in an object. The limit used to be quite a lot.
There is an issue. There's an issue in the repository that somebody tried to have more than 200 properties on an object.
Clearly not enough for some of our devs. And then experimental just in time. So Matt, I think you started explaining this at the beginning of your explanation. So do you know anything about that? Like, how come we didn't need to have JIT in Hermes for such a long time, and now they are adding JIT on top of Hermes?
Yeah. So the first thing I would say is that a sort of a JIT compiler that converts the scripting language into the native language, or even the compiled language to native in the case of like .NET and Java, it's not always a win that the user can see or feel. And so, for instance, at Blue Jeans, at PlayStation, even when I was at Roblox, it was a different language. It was Lua, but there was a virtual machine team there that was also implementing a JIT for their Lua runtime as well. And when the JIT has to run during app startup, as the sort of bytecode is getting loaded and run, and then it gets JITted and gets optimized and then gets re-JITted and re-optimized, on a desktop, on a laptop, it's fine. Like that's fast enough. The user doesn't really feel it. But in every other instance, whether it's a gaming console that has to run a full game at the same time as your app, so your app has actually very, very few resources, to even low end laptops like at Blue Jeans, having the JIT on was actually a detriment to time to interactive and time to first paint, meaningful first paint, and these kinds of metrics. And so turning the JIT off was very, very often, not always, but very, very often, a complete win in terms of getting the user into the application and making sure that the navigations and everything else were like ran very smoothly, especially when on PlayStation, where it's actually like about 40 or 50 different apps you kind of jump across as you interact. But it feels like one giant app because that's how good the app load and times were and the animations and transitions are. And so so JIT is not always like an immediate yes, you absolutely want that. On the server side, it's a different story. Where, for sort of data center efficiency and these kinds of things, there's a reason that you want more of that. But that's sort of the main thing that I think about in terms of a just-in-time compiler, where you are shipping either a text bundle or a bytecode bundle, and then on app startup, in some point of the app starting up, literally a compiler runs on the client machine to convert that into native code. And you can cache that and reuse it later, so you're not doing it on every app startup. But so there's ways to try to minimize the pain or minimize what the user can see or sort of feel. But in my experience, it was more profitable for user experience to focus on making the interpreter really fast and the garbage collector is super efficient for the workload than it was to get new turbofan optimizations out of V8. Or those were awesome, don't get me wrong, but the products I happened to be working on, a JIT was usually counter to time to meaningful first paint, time to interactive, and then the other big one at PlayStation in particular was time to navigate around, like going from page to page, even within the same app. And it turned out that in the React Native communities, various libraries that people were using were actually sort of time to meaningful first paint on app startup was great, but then the time to first navigate to a different page was super jittery and sucked. And that required work also. And not every app demands this level of detail orientation, I would say.
Plus we need to remember that mobiles are constrained by the amount of energy. Like we cannot really...
Battery life is a big deal, yeah.
Yeah, exactly. We cannot really do compilation in the background all the time, because then after, I don't know, a couple of minutes, the battery will die, basically. So even though we can cache it, we will still put pressure on the device itself. So the device will become hot, warm, noticeably warm. And then people usually, when the device becomes hot, they kind of think the app they are working with at the moment is basically a bad app, engineered in a bad way, because it's putting so much pressure and I'm not really doing anything like complex in this app. For example, I can be scrolling some kind of list, for example. So we need to kind of be in the middle, basically.
A
JIT also takes... try to be fast, but at the same time, try to be energy saver, for example.
Energy efficient. Absolutely. Yeah, exactly. And so this is where, like, if you kind of, there's two things. Well, the immediate thing that comes to mind is a JIT also takes up RAM. So if you're going to be targeting devices that had, say, 1 gigabyte of physical RAM or less, turning the JIT on is going to add possibly hundreds of megabytes to your process size, which might be fine. Again, if it's like a device that has one job, it's a QR code reader that's used in a warehouse, it's like an industrial mobile device, it's not a problem. But it is a problem if someone else is expecting to multitask and do other things on that device. And then the other thing I was going to say was, in terms of thermals, like how hot does your CPU or GPU get? If one thread kind of spins up the clock speed on one core, depending on the mobile chipset that you have, some chipsets can spin up only one CPU core to a higher rate and the other ones stay low. But in some chipsets, they all go up and go back down. And that can then generate, not just have battery draw, but generate heat. And then get thermally throttled on that single core sort of, or single threaded performance anyways.
It's interesting.
It's this stuff is so nuanced, and it really depends what part of the world are you deploying to, what's your minimum device there's a bunch of like things that kind of come into play here, and so I really encourage like the sort of listeners and viewers, like there is not really a one size fits all performance advice here. It really depends on what's your design, what's your goals, what metrics are you measuring. Like, do you have telemetry that measures time to meaningful first paint in the field? Like, are you testing on a Samsung Galaxy S6 or whatever? Like, is that a cohort of users that you're actually trying to court or trying to get to use your app that you care about? And the answer may be yes or it may be no. But you want to be really precise with what class of device you have to go down to, because that's going to direct how you gather data to know if you're doing right by those users or not. And in a lot of opportunity markets, like India or other places, I was very surprised by how much lower the graded devices were that were sold that year, because in some of these countries, they kind of get the upcycled devices from 4 years ago that people in the West traded in, and then they get refurbished and they get sold in that country by the not calling out India here necessarily, but like there's like one telco in the whole country, and they just resell these sort of very nicely refurbished devices, but they're all 5 years old when they're being bought new. And Apple does this as well. And so there's no one size fits all here. Like this is why it's so important to just be able to measure for your own app and the frameworks that you use, not just React Native, but Apollo GraphQL or 3JS or Babylon JS or BitECS or whatever.
But
Yeah,
then also, go ahead.
Yeah, I will add a single thing to this. Like, the reality is that I think the majority of users tend to use phones for maximum $400. Like, this is like average phone user will own a phone for $400, which is obviously not like, this metric is not the same in, for example, Europe and USA. It will be different in emerging countries, in Africa, for example. But the problem is that basically what you said, if you don't know your audience and you start developing and testing on iPhone 60 Pro or Samsung S23 or whatever the newest one is, then you will most likely hit this wall on those slower devices. You will be not able to kind of fix, because you implemented things in a certain way, requiring certain features to be, for example, present, or certain level of computing power present, and those slower ones,
so
they are not so great.
We've had this thing in TV development project that I worked on, where we would have like unified client app for all of the devices written in React Native, and then some of those devices would be Apple TV from 2025 with a lot of RAM and with like all of the all of the nice things. And then like on the other part of the spectrum, and like most of the users would just like run Fire TV Stick with less than 1 gig of RAM. And then what we would do is we would chop the application into tiers, and then some tier of devices would get lower grade animations, let's say, or no animations at all. And like, but JIT is also like a good avenue to like turn on and off based on like category of devices that you run on.
Is that a question?
Yeah. Like you started with JIT not necessarily being a performance gainer in all of the use cases. So I guess like for some of the use cases, you might, in the same code base, you might either turn on or turn it off.
Yeah, I think it's a deployment question at that point. And I think that smart TVs is a great example where there are some really low-end chipset TVs out there that are sold, and in fact, that's the majority of them. where every penny they can save in silicon, they do, because their margins are so thin. You know, those TVs are like $200 at Walmart in the United States or something like that. So I think that one, if the thing is fast enough, an interpreter might be fine, because the especially if it's plugged into a wall, and this is the big difference, where you can have low end mobile, where power draw is a thing also, but you can have something like a TV that is as low spec, like has only 1 gigabyte of RAM and it's LPDDR2 and all these other constraints, but it's plugged into the wall, so at least one of your constraints is relieved, which is, well, I can draw power. Now, maybe you'll still be thermally throttled, and you need to care about that. But at the very least, you have a few more tricks that you can use. To me, targeting high end versus middle end versus low end becomes a sort of deployment challenge, more than how do we make one APK to rule them all. That's not what I would personally recommend if you're trying to reach a global audience of anywhere from 500 million people upward. And so dynamically turning down animations or turning up animations, even just the logic that checks, like, do I run the animation or not run the animation? On a low end TV, you don't even want that logic in the bundle at all, right? It shouldn't even be there. In my opinion, my humble opinion. And so, and then the other thing is, for the native side of both Hermes and the native side of React Native, for those low end things where it's like, here's an ARM V5 CPU from, that was 10 years old 10 years ago or whatever, but this TV manufacturer is using it because somebody had stock and they kind of integrated it all together. Being able to compile the native side targeted specifically for that CPU is going to give you better results than some generalized binary that's tuned for a higher end CPU. And usually, in my experience, this comes down to what size does the compiler think that the CPU caches are. Where an ARM sort of V5 class of CPU versus an ARM V8 CPU can have sometimes like 8 times the amount of L1 CPU cache, level 1 CPU cache. And that dramatically affects how it unrolls loops. Can it even vectorize loops or not? And these kinds of things. And so on the higher end CPUs, even if they're all 500 megahertz, let's say, an ARM V8 CPU is going to have vector instructions that's going to make the interpreter loop of Hermes and of the JavaScript runtimes be tons faster, like instruction for instruction, than this ARM V5 CPU that might also be 500 megahertz. Or maybe even is even like faster, where it's got to do, it can't vectorize anything. It's got to all do things in like a sort of a typical
Let's say it's going to emulate the same thing, but with multiple instructions.
Right, exactly. Yeah. And so vectorization is where you can use single instruction for multiple data, and you can issue one instruction for the viewing audience. I know you know. You can issue one instruction to the CPU and say, here's a bunch of data. Here's this one instruction. Go figure it out. And inside of the CPU, it will not need to fetch any more instructions to operate on a big like collection of data. Whereas on an older CPU from even 15 years ago, for some of these lower end ARM CPUs, it can't do that. It's got to fetch an instruction, issue an instruction for every step of the loop, whether it's the bytecode interpreter or other sort of looping constructs within the VM, within the JavaScript VM. And having those vector instructions and not having them is a huge difference. When you have them, you absolutely want to use them. But if you're using them, then you can't deploy that same binary onto a lower end CPU. So in the case of TVs, which is a great example, where it's like it's plugged into the wall, so battery life is a constraint that gets loosened. You still have to think about thermals. Like, does it get hot enough that it kind of clocks down the CPU so that it doesn't continue to get too hot? Especially with an international audience, like people who live near the equator, where it gets hotter more of the time, or if you're targeting like the United Arab Emirates, the UAE, or Egypt, or Africa, or something like that, that kind of heat stuff actually comes into play a lot more than it would if you're shipping to Iceland or to the or to wherever. But I think the TV thing is very interesting and is a very legit case for people to think about. And I would point out it was actually Mike Grabowski in the very early days of Callstack did this Amazon Fire Stick initial sort of port of React Native as a out of tree platform. I don't know if it was for a customer or what, but there was a blog post in 2017 or maybe even 2016 where he kind of got an end-to-end thing working. And at that time, Amazon Fire Stick, I think, had like maybe 128 megabytes of RAM or something.
Oh, really?
So it was double check, but it was tough. it was tough, but it did drive a bunch of memory usage efficiency improvements in React Native that may still be in React Native today. But yeah, the TV is a great example of huge audience, but you have to know the hardware that the audience you're trying to get, what they're deployed on. And I think the hack there is to not have one APK to rule them all, but have a couple different APKs. You can still compile from single source. You can still, make it very efficient and clean in terms of maintenance, in terms of making sure your deployment pipelines are all clean and clear. But one thing that you can do to help yourself there is not try to have one APK that during app runtime figures out, can I run this animation or can't I run this animation? I think if you target the APK to each tier you're focusing on and include no code in there.
It's funny how you said that your explanation are only for our audience and not for us, because we know that. I don't know half of the things that you are guys discussing, because this live stream, I started doing this a year ago for me to educate myself, for me to being forced to once a week read through the news, play around with some new technologies, and listen to smarter people and sharing the knowledge. Because honestly, if you are not doing that day to day, it's really hard to stay up to date and learn about those things if you don't need that in your daily job. And if you do need that in your daily job, you are not going through live streams and learning about it. You learn about it doing the actual work, boots on the ground.
That's true.
One thing that sounded true to me in your explanation about the CPUs and the instruction of the CPUs is the correlation between one processor having just one instruction for doing a bunch of work and other processors having to fetch different instruction, with basically this, right? With the polyfills for modern language functions, where if you have maps and asyncs and classes embedded in your engine, it's going to be faster than if you have to go through polyfills and basically plug that things in some other not that optimized way.
Basically, you will have, let's say, ahead of time compilation of your JavaScript polyfills in short, in great simplification, let's say.
Yeah.
So, and you will end up with code that's way faster, without any additional things in your bundle. So
yeah. So going back to the Hermes stuff, we reached out to Matt a few weeks ago because we know, Matt, that you did some benchmarking of Hermes versus some other engines. I wonder, how do we want to show this on this live stream? What's the best way for us to showcase your work and the outcomes?
So if I have 4 or 5 minutes, I can get everything prepped. I kind of to get all my terminals prepped, and then I can share my screen and we can kind of walk through it. But we'll be benchmarking on this XR device, which is a Qualcomm XR2 chipset. This is from Pico, and this has the same chip in it that the Meta Quest 3 does.
Okay.
And a big part of the business at my company is spatial computing and mixed reality applications. And so benchmarking these JavaScript engines on that hardware has been a big focus for me. But I can also talk about the results from when we did this, it was about a year ago, with Callstack, and what Hermes was like versus JavaScript core in React
Mhm.
Native back then.
Sure. Yeah, we can start there. We can start a year ago.
Yeah. So there was a bunch of benchmarking we wanted to do, and we found a sort of a corporate sponsor that paid us to do it. And then we, Rebecca Specialties, my startup, and then per usual, I I contact Callstack and say, let's do a collab on this because it's good for the whole ecosystem. And this customer that was paying us to do it was totally cool with it all being open source and kind of everything we learned, giving it out to the community as we kind of learned what was up. And so we can load up the repo. Give me 1 second here. Actually, in our shared Slack chat.
Yeah.
That the thread that we had going, one of the links was to the benchmarking test app repo.
Is it this one?
Nope, that's our next kit. Look for github.com/Rebecca Specialty.
Yeah, this one.
There we go. Benchmarking test app. So what we did with Callstack was, this is actually a template repo that anybody can just say, make a fork of this and then add your own benchmarks in. And what we found last year was that JavaScript core was about 70% faster than Hermes in pure bytecode mode, no JIT involved. That apples to apples was really important. On a couple of really core hot paths in this sort of metaverse application from this company in a library called 3JS. And for anybody deeply curious, it was the frustum culling hot path in 3JS that was 70% faster when running in JavaScript core under interpreter mode than Hermes. That core, that's a fundamental bottleneck on how many avatars you can render at once in this JavaScript based application. So it's not like a micro benchmark or like a sort of a academic sort of, this could be a problem. This was the core scalability problem for this customer. And we don't use 3JS, we use Babylon.js, but Babylon.js has a lot of the same constructs in it that 3JS does for this same purpose. So it was illuminating for us as well. And the cool thing was that it was actually at on the plane to React Universe last year in 2024. The Callstack engineers and my engineer, Henry Allen, were reporting this information. And there's a series of crazy coincidences here that is so bizarre. It turned out that Savan, and who's the lead engineer on Hermes now, it used to be Mark something or another, and I don't know what happened to him, but now it's Savan. And he was on the plane, and on I was on, but on the React Native React contributors Discord, he was like, is this a real benchmark? Da, da, da. And I sent him all the information. And as I was getting off the plane in Wrocław, he was there, and I'm like, "Oh, you're here. Let's just talk about this now." And I was like the benchmark is self-contained, blah blah blah. Like it's all in this public repo, so you should be able to reproduce this 100%. And like my memory is that like they took a different cab to the hotel, or we're in a different hotel or whatever. But like an hour later, he's like, I can reproduce it and know exactly what the problem is. And that was awesome. But it still didn't get fixed. So we were kind of re-benchmarking, but we had what we needed, which is we were able to tell the sponsor of this work, hey, JavaScript core is the thing to use for your application right now. And again, this is because they're using 3JS, and they're in particular rendering a bunch, doing a specific kind of rendering workload. other people might use 3JS with Hermes, and this might not be a bottleneck for them. And again, this is just where it's so nuanced based on the workload that you have. There's not one single like solution here. But here's where the coincidence gets completely insane. My family and I were in Mexico at a resort, and I don't know, 6 months later or something like that. I think it was for spring break, so it was in maybe March or April 2025. And we're literally on the beach in a cabana. Who walks in front of me with his family? It's Savan, and I say, "What is going on?" I'm like, and at first I was like, it can't be him. Like, that's what a bizarre coincidence. I was like, Savan, and his wife was actually like, just like, this guy's like, calling your name, and he was like, and he's like, I'm still working on the optimization. I know what to do, like whatever. And I'm like, it's all cool. Like, we don't need to interrupt our vacations to chat about this. Like, let's enjoy the beach and have our kids run around and whatever. So that was a really lovely experience. And I think a thing, especially with social media these days, is people can get really hyperbolic and bombastic when talking about performance because they think it's a way to show how hardcore technical that they are. And so making a self-contained benchmark, making a repo that anyone can check out and reproduce it on different hardware and whatever else was really key to us trying to illuminate the whole community around being very precise about, well, what kind of benchmark? And that's why all the benchmarks in this repo are sort of end-to-end benchmarks. They aren't a micro benchmark that a JavaScript VM creator made. I'm not dissing, I'm not calling out Hermes here, but there's benchmark suites like SunSpider from way back in like the Netscape 4.0 days. And there's newer ones like Octane, which is still pretty old. That was from the very beginning of the V8. When Google was first making V8, they made a whole new benchmark suite just to show like, hey, how awesome V8 was and how everything else was bad. And then there's even a newer one that is the one I usually prefer to use called Jetstream, which is like a collection of all of these benchmarks in one place. But instead of focusing on those, we really wanted to de-risk for this particular customer. Can we take your current desktop 3D web application that uses 3JS and put it on the mobile in React Native, and can it perform? And the answer was yes, but not with Hermes as it stood sort of back then. And it's just a great example of, even if you find a problem, if you can like report it in sort of an actionable and respectful way, it can be a really awesome experience, because if/when Savan or whoever in the team like resolves that performance issue, the VM gets faster for everybody, even if you don't have that workload. And I personally, that's the kind of stuff that just gets me to jump out of bed in the morning, because it's like you can have like this multiplier impact on the whole ecosystem potentially, and it's very motivating. So yeah, there's this sort of benchmark repo, and this was in collaboration with Callstack. And so we did benchmark Hermes against a few other things, targeting iPhone 11 in particular. That was a great example of that. Customer knew the exact minimum device spec for the customers they were trying to acquire globally, based on research that they had done. It also happens to coincide with having Metal 3.2 support, which is on the GPU side of things, not on the CPU side of things. But there was so it was a great collaboration, and we ran the numbers. It must have been in September of 2024, given when React Universe was, and when that conversation with Savan was, as we were getting off of the plane in Wrocław back then. But yeah, so this is kind of the leaping off point, I would say, for the benchmarking that we can talk about today. But any questions or anything you want to go into with this, I'm happy to, with what we did a year ago, happy to keep talking about it.
So just to like recap, this repository, benchmarking test app, is a way to what, like
basically to create your own your own benchmark, or I guess run the existing ones
You can
on
run the
a farm
existing
of
ones.
devices. Yeah, on a farm of
Yes.
devices.
Yeah, or local devices. But
Yeah.
but yeah, we used AWS Device Farm for this particular thing. And so we were able to kind of, instead of having like, like the old days where you had like, 8 USB cables coming, or serial cables in the case of like old Windows CE devices coming out of your PC just to have all the devices. AWS Device Farm was, at the time we did this, was the cheapest way to run these benchmarks remotely. And on iPhone 11, be able to attach Xcode instruments and get hardware profiling data off of the device in the farm, and then download it into the GitHub worker here, so that if there is a performance regression, instead of regenerating the data on a local device, you can just load Xcode instruments data and go. There's also some stuff in here for generating flame graph data, again, so that the data is just right there for you to just download, open, and go, aha, I see what the problem is. Having that kind of a tight feedback loop is really important. And this was before the LLMs were a thing in 2024, obviously. But now there's an MCP server for Chromium DevTools. And I have nothing to show today on this, but we actually have a very nice workflow now with GPT-5 Codex, where it uses the Chrome DevTools MCP to automatically do profiling and set breakpoints and rerun the app as it's optimizing. And because we can use Chrome DevTools on the remote device, we can do this across the AWS device farm and have it have a very nice semi-automated feedback loop for a bunch of stuff that normally would have taken a relatively skilled person days to gather across all these devices. But yeah.
So this repository, you ran that almost a year, not almost a year ago, but almost exactly a year ago.
Yeah, it's funny.
Yep.
And then we have a bunch of data for JSC and for Hermes for different kind of hardware.
Yeah, specifically, I think this focuses on iPhone 11. There might be another device category in here, but
there are some iPads. I see iPhone 15 here.
Okay.
Yeah, a bunch of different things.
Okay, I forgot. Yeah, iPads are interesting, or at least they used to be really interesting, because they actually have a ton more pixels that they have to render. Even though they used to have depending on the iPad, have roughly the same CPU as an iPhone. And that disparity of you've got 4 times the pixels to render, but you've got the same compute, is actually, you might go, oh, the iPad's a larger device, that makes it easier. In some ways, it can make it harder if they have a base iPad. Nowadays, iPad Air has an M2 or an M4 or an M5 in it now, and so does the iPad Pro. So it's a little bit different now, but that base iPad running the A15 Pro, like the iPhone chip from 2 years ago or whatever, a same thing with the iPad Mini, is a little bit challenging. It's more challenging than you might think, just because you've got just more pixels to render, but not more compute.
Okay, so this is the run from the year ago with old Hermes, and there's this PR with the, I guess, updated workflow for Hermes V1, right?
Yeah, so we can talk about that real quick, or slowly. It doesn't have to be quick. So in prep for this live stream, I wanted to rerun these benchmarks and just get the template up to date here. And other people have cloned this template and used it, at the very least privately, and gave us feedback that we were fine. That's probably why we were running it still in late October of last year. And in the intervening time, a couple of things happened. One is that JavaScript core support was pulled out of the React Native core.
Yes.
And I think Oscar, who helped with this benchmarking stuff in the first place, did that work upstream and in React Native community, if my memory serves me correctly. And for people,
Oscar, Kuro, Vital, which I don't know, and then Sebastian, then Tanstack. No, Kortniko. I thought that was a. It's very similar to logo from Tanstack, right?
I
And
guess.
then Sad
Todd.
and Kacper.
Yeah. Thank you. We should give more credit. We should give more credit where it's due. Yeah. And for people who aren't aware, Oscar is the one that worked with me to bring React Native to Vision OS to 18 months ago. It's a little
More or
while ago
less,
now.
yeah.
I think you started out more than 2 years ago, and the first release was, I think, 2 years ago. Also, again, almost to the day, early December. 2 years ago, there was some kind of access already. I recorded a podcast with him at the time, so I remember.
Yeah, it definitely got kicked off in July of 2023, or I think August of 2023. Before the device came out, we were just developing on the Apple Vision Pro simulator at the time. So Oscar is fantastic. So are the other people that are contributed to this repo. But JavaScript core is not in React Native core itself anymore. And I knew that. That was the thing that I was frustrated by. That the VM diversity was seemingly going down, but then I was assured like, no, it's going to be in a separate repo, but React Native will still support it. And I was like, well, okay. But when I went to do this work in the benchmarking repo to update it to React Native 0.82, so we could get the Hermes V1 labeled thing, and I tried to reintroduce JavaScript core into it, none of this actually works anymore. And so across a couple of things, the pod spec and upstream React Native was rewritten in a way where this JavaScript core stuff broke. The CI here in the JavaScript core repo, the React Native community JavaScript core repo doesn't check new releases of React Native. So there's no feedback loop here. And I presume anybody that's still using JavaScript core just stays on an old version of React Native. And this is what we used to see a lot of in the community is people would stick on a really old version of React Native for a long time because support for something was dropped. And there was hypothetically a community way to get it back. But a lot of people don't participate in the community. They don't join the Discord. They don't ask for help. They don't go to a conference.
Yeah, they just consume and expect things to work.
But also they stay on a really old version of React Native, and they have a bad experience. They do a conference talk saying like, "Here's why React Native is not great," and then you ask like, "Well, what version are you on?" And they're like, 0.10 or whatever, and you're like, "Well, what the fuck did you think?" Like,
it's also because back then. Before any CNG in Expo, for example, to upgrade React Native, you would have to go through basically a Git diff and make sure that all the changes present in the new template are applied in your native code. And if you did some changes in the native code, then
you have to reapply them. Yeah.
Good luck, have fun. I've been there. It's not fun at all. So that's probably another reason why.
It was a real problem when I was more actively involved in the React Native community on a daily basis because of the work I was doing, where I really viewed this as like we have to like solve these problems so that people don't get the worst perception of React Native. And so anyway, this RNC JavaScript core thing does not work right now with React Native 0.82. Or 0.81, and I think even 0.80 was broken. And part of it was in React Native itself. There was a pod spec change that made it, and it was not on purpose. I don't think it made it so it only worked with Hermes. But then even in RNXKit in the React Native host sort of library in there, that also sort of bit rotted and made it so only Hermes would work. I was hoping for the live stream to go like, hey, I updated the benchmark test app, and now it works with React Hermes and whatever. And I just hit an almost complete wall. What I have in that PR branch is a local patch that fixes the problems and gets it working. But what I've done is in RNX Kit, which is the Microsoft project that kind of underlies the entire React Native ecosystem, basically. I've submitted a pull request there and notified Tommy and Saad as well to try to get that reviewed and merged if they care about it or not. If they don't, then that's fine. There does then generally seem to be an attitude that Hermes is it for React Native going forward. And maybe that's fine. I don't know. I don't use React Native anymore, so I'm not constrained by that choice. But I would say that at a high level, as a technologist, I'm disappointed that the VM diversity is going down and not up, which is something NativeScript does better. Where NativeScript, you can use Hermes or V8 or JavaScript core, whether you're on iOS or Android or Vision OS or Linux or whatever. I mean, there's finite resources and it does increase maintenance. But I am personally, as a technologist, a little bit sad that that VM diversity is one of the casualties here in this broader community. And part of it is that informed by this 3JS benchmark that showed last year that
that sometimes you need
JC
to change your engine.
Yeah, but
Right.
many developers don't even know that there is something different working under the hood. I mean, different JavaScript engine working under the hood. They may expect
I
to
guess
see the same engine that's being used by the browser, for example, because that's the usual thing. Usually, you take the existing engine from the operating system and just run your things in this pre-existing VM, basically.
I guess like a part of this equation is fine. I guess like we don't want 99 maybe percent of developers to care about like what's going on under the hood, like which engine do we use. Let's just use the one that ships with React Native because like it has the best I guess pros and cons in terms of fast startup and like direct access and stuff like that. And but for that 1% of use cases and for that 1% of developers, I think we should have easy way of changing the engine. I remember back in a day, I would like in Android applications in 2018, I would specify a different GSC in Gradle in order for my engine to be like more modern, because like the one that shipped with React Native back then was like pretty old and we'd have to do it by hand, forcing newer engine.
The truth is that without any, let's say, group of people using, for example, V8 in production and caring about being able to use V8 in, for example, 0.82 or 1.0 in the future, without such group, there will be no push from the community on the React Native team to kind of care about any breaking changes with alternative VMs, because we cannot expect a rather small group of people working on React Native to double check that GSC works, that V8 works, that whatever is also available works correctly. It's on the maintenance side of this integration to make sure that React Native is still compatible with whatever I did than the other way. Basically, there's no resources to do that.
Well, but it's not the checking, like because that's a CI thing where it's like, and I'm not
but somebody needs to create this CI. Need to create like something like test app, for example, and configure it to run for every change. Like this is also something somebody needs to do, basically.
Yeah, but that's like 10 lines of YAML. I don't know. I don't think it's the feedback loop. I think it's, do you have time or resources to react, no pun intended, to take action when that it's not the feedback loop setup. That's also commoditized now. Like it does. I don't think that's the thing. I think it's okay if it does break, then what? And I
Matt,
think that's the thing that bothers me more.
I think the question is, if this was broken for months and no one cared, do we really care, right? Like
Totally,
you were
100%.
yeah, you were the first one that found out that, oh, JSC is not working with 082, and wow, surprise, it doesn't work with 081 as well. That's like 4 months of work. That's like 4 months of releases that like it has been broken, basically.
Yeah.
So
and
there is a
wild.
Yeah,
there is some like misalignment there. Like if someone needs it, probably they would have to like flag it earlier, or
yeah, but
maybe
let's be honest.
Yeah,
like 0.80 was released. I know 5
I would say
months ago,
May,
June. So a couple of months ago. So it's not that old yet. I would say people usually in, let's say, big application, they don't update React Native so often. So we are behind the time when people will, we are basically waiting for the people.
look
to
who we have on the
start.
stream. Sorry to interrupt you. We have Svetan. Svetan, if you want to join us, I'm happy to send you the link.
Yeah, but basically, I think people will start noticing that it broke in around 6 months.
Yeah, maybe.
Or maybe around when there will be some change in React Native core that's needed to, for example, publish applications in the app stores, like 60 kilobytes alignment, for example, page size alignment.
Sure. Yeah, or
which is
winter
forcing
holidays,
people to update. Yeah. So we will see in 6 months, I guess, some issues reported. But right now,
or
it's
not. It might be that
it
might be that only I care, or it's not even that I care. Again, I don't use React Native anymore. But like, just personally, from a technologist perspective, I think that choice being reduced is, as a high level concept, is not fantastic. Similarly, if there was a Linux, if Ubuntu like started shipping Clang but not GCC, I would probably be by default, or didn't have the packages available. I would similarly be like, it seems like there should be choice there for people that need GCCs, when GCC's code gen is better than Clang's, for instance, as an example. But to Vaughn's point is a good one, and we're a little bit slightly off topic. Other than the reason we're talking about this in the first place is because we were last year when we benchmarked JavaScript core on iOS 18 or whatever it was, it's probably there in the device farm setup, versus Hermes on iPhone 11. This one particular most important benchmark for this particular application had JSC coming out so far ahead that it was kind of very obvious that corporate sponsors native app needed to use JavaScript core for them to be able to have, a metaverse experience running on the phone or iPad with hundreds of avatars. There was no and they couldn't necessarily wait for a fix to be implemented. They needed to ship as soon as possible. So and in trying to update that benchmark to get a clean, like, hey, let's just run it again, I hit these sort of complications. What's his face? Ricardo did already merge the fix in the upstream pod spec. I haven't looked at the PR to RNX kit yet this morning to see if that's been approved or merged or whatever. I'm not going to chase it down because, again, I don't use React Native. I was just trying to do something nice for this live stream. But I did patch it locally, and then did have it running locally.
But with missing GSI APIs, I mean, basically, it may be so that some native modules will not work correctly in alternative engines.
With my local patches, JavaScript core does work, and I can run the benchmarks end to end, and I can switch between them.
I'm referring to the comment that some GSI APIs are not implemented in
maybe.
V8, for example.
Maybe. But this benchmark app does have React Native Web GPU in it. and it does have a couple of other native modules in it, like React Native permissions, I think, as well. So it doesn't have 0 native modules. It has some, and those also still continue to work. But I do take your point that there might be other, or to Vaughn's point, there might be other native modules that depend on Hermes specific things. So you're really locked in, and the whole community is locked in right now. That's an interesting choice from an ecosystem perspective. And if it's working for the community genuinely, though, then there's no problem to fix, I guess.
So, like, I have this PR on the screen with your patch included. So, how about we go from this, from the benchmark from last year, to actually recreating them this time around for newest Hermes?
We can give that a try, but I ran out of time because I was trying to get it to work. So I got this literally to like all like in place and like working like last night at like 1 a.m. my time.
Okay.
So yeah, so that's why I led with we can run this on an Android device that I have locally here now, because I can tap dance and make that work. Work locally.
That's
That's something.
better. Yeah, that's even better if we can run it on a like real device for your real use case with the VR headset.
Yeah, I mean, yes, but the AWS device farm does have physical devices. They do represent what a real physical device would be, just for the users to know, like a device farm and being able to like re-benchmark your application, especially if you have telemetry built in for time to interactive, time to meaningful first paint. Doing that in a device farm can be if you have an efficient benchmarking and app launching setup, it can actually be very cost effective to do that on maybe not every PR commit, but if your PRs come out of draft, then running it to get the feedback loop going, it can be really advantageous. So you don't have to own 8 generations of every Android manufacturer's device and stuff. There's AWS. I think Azure still has App Center. I think I haven't used it in a little while. There's a number of sort of vendors that have this sort of capability, but none of them have VR device.
Whoops.
Sorry, I lost you. I changed the scene for this. So just let me know when you're ready to share your screen. I'm gonna give you this opportunity.
Yeah. Let me do 2 things. Let me talk about the benchmarks, which I have up in Windsurf right now. And I can kind of talk about the history of that. And then probably what I'll do is I actually need to put this on and select enable for the ADB connection.
Sure.
So I'll go off camera for a second and do that, and then we can kind of come back while you guys talk about.
Do you want to share the code now?
Yeah. I can do that. Let me do this, and I will share the screen. All right, and I'm going to use the operating system settings, and then I'm going to go to Windsurf and share this window. And can you?
Yep, it's here.
See that? All right, cool.
Yep.
So
I think you can zoom in just a little bit.
Mm-hmm.
Yeah. Oh, it's nice now.
Okay.
Nice and clear.
Cool. Yeah, and so this frustrum culling benchmark is a sort of a reduction of what is in 3JS. It's accurate to what the calculations 3JS does, but it really is if I remember correctly, it's the way that the array pushes are done that kind of took a suboptimal path in Hermes last year. And so, but it is kind of like taking these 3JS spheres and matrix 4 things and doing a sort of a frustrum culling check to go like, do I need to draw this at all? Like, is it below some horizon or is it occluded in sort of some way? And, to self-criticize a little bit, like, what would you actually want to do this math on the CPU instead of the GPU in a modern device? Probably not, I would say, but 3JS is incredibly popular, even though I don't personally use it, but we use Babylon.js. It's incredibly popular, and anybody doing 3D rendering is, maybe they could turn off occlusion culling, maybe. So this is going to affect almost any 3JS application, um, uh, uh, beyond some like hello world sort of spinning triangle or something. And so this is the kind of reduction of that. And last year, the LLMs were not good enough to make the reduction like a finger snap. So we had to do it manually and kind of go like, how do we, again, thinking about, even if we were talking about a V8 problem, not a Hermes problem, it would be like, how do we give the people making the VM a minimal reproduction case and kind of pre-chew it for them to respect their time and their expertise. And way back when, I don't have it up here now, but there was this tool I used to use called PCLint. That did analyze C and C++ source code. And I would spend a lot of time reducing my problems in these proprietary code bases down to a reproduction case. And it always made it, same thing with reporting issues to GCC, the C++ compiler. When you kind of reduce it down and make it an obvious test case, you're a lot more likely to get traction and a great back and forth relationship that makes the compiler or the code at Code Analyzer better for everybody.
Because the worst part of fixing the bug is basically reproducing the bug. So if you have like a short code snippet that obviously is broken, then it's up to you only to fix it, and that's it.
Yeah, and I think this just comes down to having empathy for, especially for open source maintainers, but even commercial product maintainers, just having empathy of like, what do they need to service my request better? And I think for developer tools, in my relatively long career, almost 30 years now, the effort you put in, I find that over the long arc, you get back. Because when you put your own effort in to make other people successful and their tools successful, I think people really appreciate it. I think it's been my experience. So this is that 3JS sort of reduced down. There's another benchmark that comes from the Jetstream, which is on browserbenchmarks.org, I believe is what it is. This is one that I used several times as a reduction of a proprietary piece of code. When I was working at LG on WebOS, which is the sort of browser-based app operating system that runs on high-end LG televisions, and we were switching at that time from WebKit to Blink, which is Chromium. This benchmark was basically reproduced a performance problem we had in a private app source base, it has a red-black tree data structure that it rebalances and some other stuff. And this is something that you might see in a great many applications. It's sort of an algorithm benchmark that is end-to-end enough. It's called CD because it's doing collision detection. So this could relate to gaming, could relate to other kinds of things like, trying to figure out what I can say. Let's just say it's a good benchmark.
Yeah.
And this is reduced because what I try to do for all of these is make it so I could paste them in as a one-liner onto the command line when we run them on the device, so that there's not multiple files all spread out and that kind of stuff. So it's kind of I formatted it so it would be readable here, but this comes in at about 3.8 kilobytes when it's all sort of on one line. And that's why it looks a little obfuscated. And then here's the little thing I put in here. And for all of these, being very careful not to measure the time spent in bytecode compilation. For all of these, we want to assume whether it's JavaScript core bytecode or V8 bytecode or Hermes bytecode, that happens not on the client device. So I'm personally not interested in that. I'm only care about in this bytecode only interpreter, how fast does it actually execute the bytecode? So there's some ways that we're invoking JavaScript core in V8 using their C++ APIs to make sure that we're using it correctly in that way, because Hermes typical deployment does not compile bytecode on the client device either. This is the whole thing we talked about, is deploying bytecode bundles like we did with Chakra Core in Windows 10, in 2016. We want that uplift. It's Hermes superpower, and JavaScript core and V8 also kind of have this superpower capability now, and that's what we want to compare like for like here. And so that's why we don't put the console time around the sort of closure that we're using to generate this stuff. That's not relevant to what we're trying to compare here. And then the last one is a bottleneck that we actually found in Rebecca's application, where we are loading a lot of this file format called VRM, which is basically a different file format called GLTF. That's a standard Kronos. That's a Kronos standard for 3D models, and VRMs is kind of the standard for 3D avatars for spatial computing and metaverse type applications. And there is actually, when you have really complex avatars with really complex materials, and you have them with behavior graphs, where you can have it so that when the user clicks on a part of the 3D model, the behavior is built in to the model format itself, and you just ship one file that has the interaction behavior in it. There's actually a lot of JSON in this format. And when you have complex materials and complex interactions, the JSON parsing can actually, in the JavaScript engine, can actually be the bottleneck. And so this is new. There are JSON stringify and parse benchmarks out there, but this is something that came up for us recently, where in terms of how do we get the avatars on screen faster, as early in the app startup as we possibly can when you go into a new space, if you will. And so we're kind of exemplifying that here by making this data, making an array of a bunch of things that have the physically based materials sample data and some behavior graph sample data. When nearly every vertex in the model can have an interaction capability, it gets pretty hairy pretty fast. And we found that this was actually a bottleneck for us in getting the interactive 3D models and avatars on screen faster. And so it's pretty easy to understand. We have this JavaScript object here. We fill it up with a bunch of sample data, and then we kind of stringify it, parse what we just stringified, and then we kind of restringify that again, and see what happens. And it's actually pretty interesting, the gap for this particular use case. And again, just to reiterate this, different VMs are good at different workloads. There are design choices in the JavaScript interpreter or garbage collector or ahead of time JIT or ahead of time native compile or JIT compile or whatever. There's like 1,000 choices on each of those branches of how you design the whole system. And making one choice or one trade-off versus another isn't necessarily a black and white good or bad decision. It's what are you trying to do in the application you're trying to build, or what are you trying to do that's different from these other VMs choices and whatever. And so for these particular use cases, these are ones that are relevant to me based on my experience, and happens to coincide with that corporate sponsor, which is why it was such a great collaboration, because we got to solve, I got to solve Rebecca's problems and their problems and the community's problems sort of at the same time by measuring this stuff. But these are the sort of three I've reduced down to for testing across JavaScript core, V8, and
Hermes.
Hermes. And very specifically, in the JavaScript core build that was used for React Native on Android to deploy JavaScript core there's a pull request that's up that I put up to update that to the latest JavaScript core that's used by Bun. A lot of the JavaScript community loves Bun. It's a much faster developer experience than Node.js in a bunch of ways, or at least it was a year ago. It was really hot stuff. And they're doing a really great job keeping their fork of JavaScript core up to date with upstream WebKit. So it has all the latest stuff. And latest stuff is optimizations across the board, including in the interpreter only, which is when JavaScript core runs on your Apple Watch, it's not using a JIT because not enough RAM, not enough CPU. But also built-ins, just like Hermes' announcement talked about having map and stuff as built-ins that you don't have to polyfill with JavaScript. So your JavaScript bundle is not only smaller when using these standard objects, but it's also a ton faster to do that stuff in native code versus having a JavaScript polyfill that the interpreter has to run on. And a really great example of this, we talked about vector instructions earlier, is something like Stringify or something like Parse, where if you have a native implementation that is really leaning into the vector instructions of ARM v8 or like the Pixel 2 and above, or a Samsung S7 and above, or MetaQuest 3 or Pico 4 or above, these specific things can get a lot faster, like so fast that you think the benchmark is broken faster, versus if it's a polyfill.
On the same kind of principle that we discussed an hour ago, meaning either you run just like one command and it works, or you have to fetch like 5 or 7 different ones in order to do the same thing. So like one tick of your processor clock versus like 10 or 12 or whatever.
Exactly. Yeah. And so we talked about like the 500 megahertz ARM v5 CPU versus a 500 megahertz ARM v8 CPU. And even with the same memory bandwidth, potentially, you can get a huge difference between those two, even though they're clocked the same. And, especially I feel like in the PC gaming world, there's this sort of up and to the right numbers, like how many gigahertz is something or whatever. And sometimes the marketing numbers that people who think that they're technical glom onto, they actually get worse performance than something that has worse marketing numbers just because it's a better architecture or whatever. But yeah, these are the kind of three sort of real world, based on my experience, sort of benchmarks. And I'm not trying to be exhaustive, and we talked about maintainers and volunteering their open source time, and they don't want to fix everything. No one's paying me to do these benchmarks again. So, but the thing I thought was really cool that we did want to revisit was this is the benchmark last year that showed that JavaScript core was notably faster than Hermes. And then we've got these other ones for funsies. There's another benchmark in the benchmark test app repo around bit ECS, which is an entity component system. And we found that some bit ECS benchmarks were faster on JSC, some were faster on Hermes, some were faster on V8. They're all kind of neck and neck, more or less, for that one. There was not like a clear a clear like winner, like Hermes is 9 times faster or anything like that at that time. And so
I like how one of the benchmark in benchmarking test app is called simple benchmark, and it's just a promise set timeout thing.
because a big concern was, if you aren't very careful, you can have timing variances between benchmark runs. And actually, a big thing of running it, not even in a device test farm, but even on local devices, is turning off all background services, turning off anything else that might be distracting the CPU and adding noise or kind of stochasticity into your benchmark runs. And that simple benchmark is meant to show that should basically be 0 all the time. And if it's not after 1,000 runs, it means something's going on the device where we can't trust the numbers coming out of it. And so that simple benchmark has been as a sort of a level set calibration point for the rest of it. And so we needed something that would not immediately be optimized by even the bytecode compiler, just optimized away. It had to be a sort of a non-zero runtime thing that was just big enough to show like, here's a not 0 workload, but a level 1 workload or whatever that the bytecode optimizer doesn't optimize away. And so that's what the purpose of that particular one was to get a level set of, okay, when we do the most basic thing that doesn't get bytecode optimized away, it takes this many microseconds. So we know on the rest of these benchmarks, to even them out, we'll just subtract that number of microseconds so that we're focused on the real difference between these VMs for that workload, not the table stakes of the device at that time. And so it took a lot to figure out how to poke the iPhone settings in the device farm to turn off stuff. And frankly, the reason why I'm using a Pico 4 Ultra here instead of a Quest 3 is on MetaQuest 3, after about firmware 78 or so, there is so much background services and stuff going on for Horizon Worlds that you can't disable. If you disable it, it bricks the headset now. And so I can't really use it for level setting benchmarking. Even if it's in airplane mode and whatever, it's still got a lot of stuff spinning all the time. And I found that I can't reliably benchmark on that. There's too much stochasticity in the numbers no matter what I do. And so that's why I'm using the Pico 4 Ultra, because it doesn't have all that stuff on it running all the time that you're not using anyway. But yeah, that's why that simple benchmark is there. And that's why I'm not running it here. I guess I could to try to get a level set, but I think if we just run these things 10 times on the device, it'll probably, we'll probably see what the spread is, and we will know pretty definitively. I think there's some obvious gaps here between these VMs that we will be able to see.
Cool. Yeah. Let's go. Let's
right.
do it.
Let me, I'm going to stop sharing this window, and I'm going to turn off my camera for a second.
Sure. Yeah. Well, me and Szymon will take over the commentary right now.
No worries.
Okay. I love the comment from Mike.
Yeah.
Saying that Matt should be our full-time live streamer. I agree.
Oh, thanks, you guys.
Too many interesting things to say. In the meantime, I looked into the code for the benchmark itself, and I think I don't see any. Do you want to make some predictions? No, I don't see any mentions of garbage collection. I don't see any garbage collection being invoked before testing and after testing. So is it like you run only one run? No, you need to run at least 100 of runs, right?
Yeah, but in terms of like, does the workload like cause garbage collection?
Okay. Yeah, the faster the collector is, then the faster the code will be in practice. So it doesn't necessarily need to be subtracted or
Right,
yeah,
especially in a tight loop, relatively tight sort of hot path loop like that. Like if the garbage
Mhm.
collector halts the main JS thread to do its work, that's going to show up in the benchmark. If
Yeah.
the garbage collector kind of is on the same thread in some way or spins up another CPU core and the device starts to throttle as a result, that's going to show up in the benchmark. So we could dive deeper into piecing apart like, okay, well, what about these is slower or faster? And my nerd brain is very interested to know, but my practical adult brain is I don't have anything driving me to go into that level of detail. For me, right now, benchmarking on the devices I'm trying to deploy my application on and having the benchmarks, why it's faster, why it's slower,
Hmm.
is I'm curious, but don't have time to spend the 4 days it would take to dive into profiling the native code across all of these VMs on the device. Similarly, I didn't go into low-level hardware profilers to look at, okay, what are the L1 cache miss rates on this device for this VM versus this other one? Like, I'm curious. I'd love for someone to publish that because I am curious. But for me, it's just like, which one is faster right now, and can I make a reduction of the benchmark and hand it over to the VM team? And they're already warmed up on that profiling and optimizing tool chain. And I feel like I've done my bit for king and country if I've given people actionable feedback at this point. Like, to be clear, if someone wants to pay me to do another like deep pass on the stuff, I'm super interested to do it, and it does help Rebecca's product and helps us get to 120 FPS on these XR headsets, and or to high frame rates on very constrained devices. I can show you one in a second. Like, I'm happy to do another pass in this work, but the reason we were able to go so deep because it was funded. And that meant that we could kind of like, okay, well, I don't have to worry about making, generating revenue to make payroll for 3 months. We can literally focus on this. It helps our customers, helps our product, but it helps the whole ecosystem. That's great. Like, more of that. Someone wants to pay me to do more of that, pay being the team to do more of that. I would love to do more of it. There's more we can learn. There's more we can uplift across the whole JavaScript app ecosystem, not even specific to Hermes or React Native, by getting detail oriented about this. And this is what I love about working with Callstack. It'll in 2026, the coming year, it'll be 10 years from when the first time I worked with Mike, when Callstack was him and Anna and one other person when I was at Blue Jeans. And this is the thing I love about working with Callstack is you guys are just such great partners on just getting into the goddamn details and being really specific about it's slow. Why? What can we do? Slow versus what? Like, there's all these, just really getting into the facts and reproducible, not being bombastic social media personalities, but it's like really like enabling the community to do their own measurements and get detail oriented. And I feel like it's hard to find a partner that has a team that can consistently do that across a decade. Like, I'm not saying it doesn't exist. I'm saying it's hard to find. But I'm
Thank
almost
you.
done.
That's really cool to hear. I love working at Callstack for that exact reason, that I'm able to interact with really, really smart people, where I'm almost the dumbest in the room in many occasions, talking about like different kind of technologies, like here, like on this live stream. That's why I do it, to learn.
So how long have you been, Łukasz, in Callstack? 5?
It's
3?
coming
2?
up to be 5 in a few months. 5 years.
Nice. I've never been in the same company for more than 2 years.
Me neither. Me neither.
We will see how it goes. I'm 1 year and 3 months right now in Callstack, I guess.
And you've already been doing such a lot of work in the community, like building libraries,
wouldn't
creating
say.
tools.
Last 3 months, maybe 4. So I'm getting started. Hopefully I'm getting started. Yeah, that's why I'm also tinkering. I'm not tinkering, but looking into the source code of benchmarks, because technically the same approach I used to build harness can be used to build some generic benchmarking tool for React Native.
Mhm.
Like spin up the whole app, then pass only the benchmark data and some
run on developer.
lightweight runner. Yeah. And for example, use jest to run it and present the results. Not build another CLI, for example. Yep, writing it down on my to-do list for the next couple of months, and we'll see how it goes.
Nice. Yeah, I commented to Mike, or I'm just like, I don't know, how do you keep finding these people? Like genuinely, I'm super curious about, like, is there something in the water in Poland? I'm, because obviously, like, something happened in the schools seemingly countrywide some number of years ago, and I'm there's a sort of a social aspect, not like social like media, but like there's like a societal aspect of this that I feel like has resulted in this amazing outcome, and I'm like nerd curious to understand, like,
I wouldn't say schools in Poland are, well, above the average. I would say certain schools in Poland are below average when it comes to teaching, but I guess it's because, like, we were curious about the West, for example, after the Iron Curtain was basically destroyed, let's say, and after we basically started looking more to the West than East, and maybe that was pushing us to, for example, our parents pushing us, like me personally, to, for example, learn languages or maybe basically pursue my, like, dreams, for example, because I always wanted to be a software engineer. But technically there's nothing special in Poland. I mean, we don't have any special schools. We don't have any, like,
but if
special
you look at the
attitude.
history, we've always had a bunch of like really talented mathematicians and physicians, and like IT on these like Olympiads of IT like competitive programming or something, like polls are always like high in the rankings. So I guess there is something there, like in our, I don't know, society or like tradition to like
maybe
follow this kind of
maybe this thing that we are taught to always try to repair things, like
making use of what you already
like problem
have.
solving.
Like,
Yeah, problem solving. Maybe that's how we learn when we are young. We learn how to kind of basically solve problems, and when it comes to software engineering, we are basically solving problems all the time. And maybe that's why we kind of, for example, come up with some unexpected ideas, for example, that then turns out to be, well, maybe not the best options, not the best option to solve the problem, but like the most efficient way to fix the problem. I know, hard to say.
let's try to bring it back to Hermes.
Sure.
I was about to say the same thing, because we can always tell nice things about Poland and Callstack, but right now we are supposed to talk about V1. And maybe while you are working on setting up the whole thing, the next part of V1 we didn't really talk about is the outcome of implementing so many new features natively in the VM. So right now, part of building pipeline for React Native is Babel and transpilation, basically adding transpiling code from one form to another because we are missing some syntax, for example, some native features of the language itself. So now with V1, we can basically go through all the Babel plugins we have enabled right now for our React Native apps and probably turn off, 30% of them, maybe 50% of them, which is cool because, well, the app will be smaller. This is the first advantage. And the second advantage is that technically our build times should go lower. Not sure how much lower. I wouldn't say much lower, but still even 5% or 10% is a good opportunity to basically to use V1. Because 10% doesn't sound much, but 10% of 3 minutes, it's something. 10 minutes is a minute. It's something. Yep. So what's the status? Are we ready to do something and see something, or?
Yes. I'm just getting the commands. I could do it on camera so everyone can see that I'm not a genius and that I fumble around doing basic stuff.
All people use AI now in everything, so you should say that, right now I'm running my own agent and I'm telling him to run the benchmark.
I'm kind of doing that because when my command line when my command line didn't work right away, I was like, just give me the command I can sort of paste. And so, but I can just kind of like walk through this. So I kind of showed the source files for the benchmarks earlier. And so for Hermes, by the way, there is a cross compile for Android documentation for Hermes that's in the repo. It's like has been updated in 4 or 5 years. So the reason I knew about the Maven publish is because I looked at their Android CI to find out how to actually build it for Android. And so we need to, so I've built Hermes locally and I pulled main, and there's not a lot of updates beyond the sort of V1-ish tag. It's mostly deployment stuff. And so I have Hermes C, which is sorry, let me make this bigger. Make that bigger. Is that visible reasonably?
Yeah, I think so.
Yeah.
Cool. Cool. So I have Hermes C, which is my host build. So that's running on my MacBook here. And what that does is it's going to emit the binary, which is the bytecode file, this .hbc file. And it's taking in this JavaScript file to do it. And so let me and there's just something with trying to get fancy with this that it doesn't quite like. And so out, there we go. So, and then I'm saying, and then do it for this next one also, which is again, Hermes C, emit binary out. And that's for the CDJS, the collision detection JavaScript, which is collision detection is incidental. It's a red-black tree data structure that rebalances, and that's like the important part. That CDJS actually used to make WebKit, Safari itself, like beach ball, because of just it was a workload that was so tough on the garbage collector and stack usage. And then we are doing it again, Hermes C emitting the binary for the 3JS frustum culling benchmark. So we are running that. And
So are you just starting running this, or it has been running for this whole time?
No, I just started running it.
Okay.
I just started running it. I kept finding like, oh no, I got to have a backslash there, like that kind of fiddling. And I was like, probably is not good for live stream. But this is taking long enough that I think I'm actually going to reduce this down to just one. And in fact, let me just do that part there.
Maybe it's because there's something running in the background, because I see two lines saying running.
In the codex, yeah.
Yeah.
Oh,
So that's-
yeah. I don't. This is not doing very much. Here, I'll just tell it to stop. We shipped a native script application to Apple Vision Pro around March of this year, and I'm updating that application for Vision OS 26 to help test the native script 9.0 alpha build, which is a topic for a different time if anybody would ever be interested. And yeah, this build of the Hermes compiler is not. Let me just.
It's slower than expected.
Yeah, and yeah, it's taking longer than I would anticipate, which is annoying. And I fully admit this might be a pebcac problem exists between chair and keyboard where I mess something up. But obviously it does run because this is its help file. So it's in the macOS binary file format. It runs. It doesn't crash on startup or anything like that. So let's just let that run. And maybe it just takes longer than when there's a spotlight on you on a live stream to complete. And we can
Is there-
switch to
Is there a
one of the
flag
other VMs.
to like enable verbose so that we can see
Well, that's a
what
good-
it's doing?
Yeah. Nope. How about Josh verb? Oops.
No.
Let's try dash help and just see. Get to version help list. Trace the inputs into bytecode, basic by species only. Not.
I didn't see anything like that.
Yeah, I'm not seeing anything like that either. But there is sure a whole lot of things here. You know what we can do is that we can try something slightly different, which is that we can just use Hermes and just run it on the JavaScript file. Because I wonder, for some of these benchmark files, we talked about Hermes has more built-ins now. Great. I still had to modify some of these so that they were parsable. Like I couldn't do ES6 classes inside of a function closure, for instance, which the other VMs could do. Oh, darn it. I may not have built it for Mac OS. What do I got? Hermes lit.
Whatever it is.
Yeah,
Python.
and that's looking for Python. I actually have no idea what that is. What I can do is we can go back to our previous command line, which was just how do we get these things on the thing itself. And so I have my command line here. I hate Claude when it does that. So let's try this. Give me the command to run the JS files on the device without bytecode compilation on the host first. And the reason I'm kind of doing this is that I wonder if when I ran these last night, I wonder if I lost my changes where I kind of massaged this in a way that Hermes liked better, purely from a JS syntax perspective. I've only shared I shared my whole thing. I'll just show you. I tested these in all of the browser consoles in Firefox and Safari Technical Preview and Safari and Chrome Canary, and to make sure, is this basically like work? And then I ran them at the command line for the JavaScript core build and for the V8 build as well to make sure that they all worked. And then Hermes still needed a few little tweaks. There's some little bits of syntax I didn't quite understand. And it was mostly in here where this used to be inside of an ES6 class inside of a function closure, and Hermes couldn't do that. And then, to be clear, no one does that. Like that's just was just from the minification sort of process that did it that way. And so, for instance, this is the exact thing. So I pasted the wrong version here. So this one I'll have to adjust to get Hermes to work. It can't do ES6 classes inside of a function closure, which is legit code. It works everywhere else, but won't typically come up for most people probably. So I'll need to adjust that. But even when I put this into Hermes before, it told me like, hey, this doesn't work. It didn't just hang. So that's why I think something else is up. So let's go ahead and run this. We'll skip the bytecode compilation part and see what we can do. And I said, give me a pasteable thing, and it did not give me a pasteable thing somehow. That one. That might be it. Okay, we'll try it one at a time. Like we're, so we'll do an ADB. I'll just do one of these. Specifically the JSON loop, because that's the one that I know is not, will highlight a difference right now. That worked. And then we are going to push the compiled Hermes binary to the device. Requires, and what did I mess up? Yeah, this thing where it's like, give me a pasteable thing, and then like, but you can't because they're TUI. You can't actually copy paste a multi-line thing. It's not nice. All right, so we transferred over the locally compiled Hermes binary, which is an optimized build. And to get these all on even footing, they are all optimized for ARM v8A, not ARM v7. So they all have an opportunity to look great, to impress us. So now we're going to push this lib Facebook JNI thing, which is necessary for some reason. Okay, where is it? No. Where is it? Lib? Maybe I don't need it. I'll just say staging Hermes release. Let me just do a search here. It is in there. There's just something maybe slightly wrong with the 2z / obj. All right, there we go.
Okay.
That thing. Fuck you, you can't. What are you talking about?
Now we are comparing two strings, looking for.
Yeah, exactly. So instead of doing that shit, I'm just gonna copy
release.
the whole thing
There is
again.
CXX missing.
Yeah, something is not quite right. So
Hermes working there / Hermes / CXX.
That works now.
Yep.
Instead of playing Hunt for the Pixels, as much as I like Hunt for the Pixel video games, like Broken Age and Secret of Monkey Island and whatever, I don't like it on a live stream. Let's see. So there's that, and then there's pushing the libc++ shared onto the device as well. And there's more crap here. Give me a break.
So it's definitely not that easy to. Okay, I think you pushed the whole.
Did the JNI, but for the libc++, it did not. Star so star print. Yeah, there's just something slightly off about the paths that Claude that Claude spit out for some reason. And that's okay because we have Unix commands and we can run ripgrep as well as good as anybody. Cool. And then we need to set that to be executable.
Yeah.
So it will run, and that's fine.
And now it's time to run it.
And now it's time to finally run the goddamn thing. So we did the JSON.
Yeah, which one? I think this is the one.
Yeah. And there we go. Property console doesn't exist. So we have to so this is a built-in that's not included when you compile Hermes for the command line. So here we go. We'll just ask the symbol console doesn't exist in Hermes command line by default. What is included that I can use to output.
I just realized that the stereotype for software developers is that we don't really communicate. Like we are very shy, very how's it named? This trait of people. Introvertistic, let's say.
Or introvert, or
yeah, we are introverts, and now our job is becoming more about writing stuff and let's say talking to computers than writing the code, which is kind of fun, to be honest.
Yeah, there's definitely like a full circle thing for me where, like I worked at a company that built an internet provider in the mid 1990s that ran on Linux, and at the time Linux was very new, and so when you deployed it, there was always something to fix or to enhance to make it work better. And so all that collaboration and sending patches to Linus and whatever, that was all just email and IRC. Like, so you never met anybody. There was no video chat. So I feel like in some ways I'm back to being on like where Codex and Claude Code is my IRC client in some ways in terms of like whatever. But I feel like also having been a senior technical leader in my career and mentoring people and needing to communicate not the micro details of exactly which keys to press on the keyboard, but what the intent and the values are so that a more junior person can self-reason about how to do things and use their own creativity rather than telling them exactly what to do. Being able to communicate high-level goals that are give enough detail to be actionable, but still allow you to be surprised by like a creative solution is, I feel like, a lot of things in my career were practice leading up to this point. So, and you can see I'm using Claude and Codex because they're good at different things, I have found. And sometimes Claude gets stuck and I'll switch over to Codex and vice versa. And so Codex for C++ build stuff, I've found like the JavaScript core WebKit build or the Chromium V8 build in my personal experience with it. I'm not making a blanket statement. I use both tools. I don't have a horse in this race, to be really clear. I've gotten a feel for exactly what these things are better at and what they're not as good at.
Yep.
And I do reevaluate the other tools every so often. So let's see what it came
Every
up with.
model has different like traits, let's say.
Yeah, exactly.
Those
yeah.
are good at programming. They're really good programmers. On the other side, when it comes to some general knowledge, let's say, then for example, GPT is better, at least in my opinion.
Yeah.
But for example,
Yeah,
Gemini
I
is a
would
great
agree.
writer. Like, I like the style of Gemini, for example.
Yeah, and I have
The second console is still there. The last
yeah, I'll
one.
get it. I'll get it.
Oh, right, because now we won't see any technically would see with time command, but
It
So
should be outside of the loop, right? Both of them.
we could we could get the aggregate instead of just the first one. I'm cool with that.
it will be faster to see at least the one.
I mean,
Because-
how much? If date.now is that much slower, then maybe there's some other. maybe it should be a date.now benchmark. But what does this want? It wants me to do 100. We're only doing 10 because these have 100,000 entries. So trust me when I say that these are fine. So we're going to come back to here and we're going to re-push our our source file.
Because we are not compiling it to bytecode, right?
Correct. Yeah, it's not running. So we try to compile it and it hangs. Even when we switched gears for a few minutes and came back, I'm still thinking about it, and it's not a large file by any stretch. Feature request, one, verbose mode. What is it even doing? Is it stuck? Like we could attach GDB or LDB and set a breakpoint and do a backtrace to figure out where is it. I feel like that might be a feature request for Hermes C. That would not be wholly unreasonable. So let's now try running it again and seeing what happens. And does it print anything?
It still
Thinking.
runs, right? Yeah.
Okay, there it ran. Okay, great. So, and that's running here on this device with the cable enabled. Hopefully it didn't just go back to sleep when I have to like stuff a thing near the eyes so it thinks that someone's wearing the headset to make sure it doesn't go to sleep, rather than having it on my head sideways. Like
I worked on I tried to create my own app for one of the Google's, like I think it was MetaQuest 2, I guess, like a year ago. And the most like annoying thing was to kind of fake wearing it, like having one eye inside and the second eye looking at the the screen, just to make it not sleep at all, because it would turn dark in a second or two.
Yeah, there's a config thing I can do on the Pico 4 Ultra where you can flip it so it won't turn off, because you can actually use the stereo cameras on this to record 3D videos for TikTok, which is cool. I haven't done it. So they do have a config setting. I just am too dumb to turn it on. So we're getting pretty consistent sort of results here from this GLTF JSON loop.
It's rising for some reason. Like
it's what?
It's rising. The number of milliseconds is rising. 640. 622. Okay.
Not entirely. It's there's some vacillation here. But now let's go and change this back to console.log. And let's do this for, just checking on the time. Do you want to do V8 or JavaScript core?
Let's do JSC.
JSC? Okay.
Yeah.
Let's see. So this is V8, and here I am in V8. So there's a couple things that I did as part of this, which was there's two projects. One is called JSC Android Build Scripts, and the other one is called V8 Android Build Scripts. It's like here. And these were used when React Native still supported more than one JavaScript VM. These folks maintain the Kudo, who's awesome, obviously, maintain these builds to get these to compile for Android for deployment. But actually, these things are used outside the React Native ecosystem as well. So these same repos are used to get V8 packaged for Babylon Native, and I think for NativeScript as well, potentially. If I remember, I believe that's correct. One outcome of preparing for the live stream is that JavaScript core Android build scripts, JC Android build scripts, is synced to Bun's fork of WebKit, not the really old GTK2 version. And that gets it basically on the latest iOS 26 version of JavaScript core, which is awesome. And then V8, same deal, is getting that updated to V8. I think it's 14.3. Just got deployed to Chrome desktop and Android stable. And so whether these ever get used in the React Native community again or not, there is the greater JavaScript app ecosystem of Babylon Native, NativeScript, Links, JS, and other things, where these things that started out as these React Native driven projects, even as React Native has moved on from these VMs seemingly, they still provide a lot of value. And so updating them for this actually helps the whole JavaScript ecosystem. But let's go into JSC Android build scripts. And this branch is submitted as a pull request to JSC Android build scripts. This is how I know, this is how I found out that the JavaScript core support in React Native has regressed so thoroughly. And so here's a one-liner, pushes the ARM64 bundle. All right, let's see if Codex does a better job with its one-liner. I see, again, I just don't think, I think you got to paste it line by line, which is just.
Let's try all of this at the same time. This is like formatted much better than the previous one.
Maybe, yeah.
At least
sure.
it looks like a one line and not like a bunch of different lines.
Yeah, let's nope, same problem.
Okay.
Which is okay.
We tried. We
tried. This is good feedback for Codex and for whatever. When I say give me pasteable text, it better be pasteable text. I don't know how to make it more specific. And it's their TUI library that they're using that adds, basically makes it scrollable. Like I understand why, but yeah, I understand why it's happening, but it doesn't make it less annoying. And I bet you there's some.
Basically, it's not native wrapping of text lines, but rather
it's not. Yeah, there's invisible things. Actually, I think it's in the leading. I think there's invisible things here that mess it up. Cool.
Undefined.
I'm less worried about that and more about this time milliseconds here for our GLTF JSON loop. So let's focus just on that, since that's all that we got to run in Hermes as well.
3.5 seconds, and for Hermes we got 4.5. 3.6. Nearly 3.6.
Yeah. And just so everybody knows, this is what benchmarking is. Like, it's not glamorous. Like, but again, when you zoom out to the end-to-end product and what's the user experience, or case of like a metaverse or a spatial computing app, it's like if you can go from 50 avatars in a scene to 200 avatars in a scene, that's a leapfrog in terms of how you think about social experiences in XR and stuff. And so it is very tedious and very low level, but again, when you do this with a goal of an end-to-end product outcome, and that's what you're truly focused on, it can be very worthwhile.
Yep. So it was 14 seconds.
Yeah. So this is something that I knew from integrating Hermes in a private branch somewhere that's not going to be published because it turned out to not be worth it. But I was curious for this JSON deserialization of GLTF data formats and VRM data formats. I hypothesized this was going to be a bottleneck, generally regardless of whatever VM. And so I need to know which VM was going to perform the best for this use case, because streaming in that data, getting it decoded, and getting avatars spatially present faster. That's the user visible sort of goal there. And yeah, when I tried that integration of Hermes into Babylon native and tried it with even 100 avatars, I was like, it was noticeable how much more slowly the avatars popped in. And I kind of did the profiling to figure out this is at least the immediate thing it comes down to. Often with profiling and optimization, you find the top, the long tooth that makes everything slow. You optimize that. And then once that's optimized, then you can see what the next thing underneath it is. And right now for Hermes, for this particular use case, which is totally subjective and is what Matt Hargett and Rebecca Specialties is currently focused on, Hermes is not the best choice here. And V8 and I want to be mindful of the live stream time. V8 is similar to JavaScript Core's performance here. V8 is actually slightly better when running on this device. And so this is one angle where Hermes, depending on what they prioritize, could have catching up to do. Or they might say, well, we don't care about these kinds of apps, which is totally cool, by the way. This is why VM diversity, I think, is really important, because the different VM teams that have different visions and different architectures and different things that they prioritize.
So
and
Matt,
that's okay.
Do you think this is like going forward? Is it necessarily a trade-off? So the question is, can we get a JavaScript engine that is best performing in every benchmark, in every scenario? Or is it a trade-off that some of them will be focused more on some use cases, and then neglect is not a best word for it, but like not be as good in other ones because of trade-offs, or because of what?
Yeah, but I think the thing is like we're talking about a benchmark here that gives us wall clock time of how long did it take to execute. But what we're not measuring right now is what's the power draw in the SoC while that benchmark is running, and is it different between the VMs? What's the binary size on disk of the VM for it to have that performance? How much RAM does it take up at the peak of running the benchmark?
Mm-hmm.
These are more dimensions that could be really important, like when running on the low end TV, for instance, where it's like, hey, I've only got 512 megs of RAM or 256 megs of RAM. So I actually don't care if the benchmark is slower. It just needs to fit in the RAM that I have. So we just looked at wall clock time for one particular use case. I can keep going on the screen share, or I can stop it now. What would you like me to do?
You can. I can just kick you out of the
Okay.
screen sharing.
Hmm.
Yep, that's
Yep.
done.
So we have these other benchmarks that I might get running, and maybe I'll post on Blue Sky about it or LinkedIn about it or something. I do have a business to run, so maybe I won't, because I already did the benchmarking I already did this benchmarking like maybe a month or two ago with Hermes and Babylon Native, so I kind of know which VM is best for us right now.
Mhm.
But in terms of like, could one VM be the best at all of the benchmarks? Wall clock time, maybe, but wall clock time and RAM usage and power draw on the mobile SoC that you're targeting, I'm not saying it's infeasible, but I'd say in my 40 years of programming experience, about 35 of those years involved sort of hand optimized assembly in some cases. There is like, how much RAM do you want to use versus how much compute do you want to have versus how much disk size do you want to take up?
Yeah.
And usually these levers are, you pull one and another one moves, right? And then what's the runtime performance?
You can have it fast, you can have it good, or you
Small,
can have
yeah.
it cheap, and you
Oh,
can
yeah,
only
sure.
choose two.
Yeah, exactly. So similar balancing thing. And this is where someone could probably really school me on, no, you can't have it all, and here's why.
Mhm.
And that would be awesome. I'd love
No,
it
but
if
it does make sense. It does make a lot of sense the way you explained it, where it's a trade-off between you said clockwork time,
Clock time.
wall clock time.
wall clock time,
Yeah.
and then like the amount of RAM it needs to run, the bundle size, etc., etc. Yeah.
Simple cases that you can simply turn off garbage collection if you have enough RAM, and if so, you won't pause
Right.
for collection.
Yes.
So it'll be faster.
That's a really great example. That's awesome, because that is like I remember with Smalltalk or early days of Java in the mid 90s. It was like the early days of Java in the mid 90s. It was slow, but the way that some companies made it faster was they just disabled garbage collection in their Smalltalk, in their build of Smalltalk. You couldn't do that with Java, and it's like, now it's faster, but the program will only run for a certain amount of time before it runs out of physical RAM on the device. But it's a good example, because some people, this is where just, again, it's so nuanced to talk about performance, where it's like, I did it and it only took 500 microseconds, but there's more detail that you need to know to go like, okay, but in what context, on what computer, on what device, and whatever. And I've absolutely personally made the mistake of benchmarking the wrong thing, where I go, oh my God, this one's so much faster. Like, it's on the order of microseconds instead of milliseconds. That's better. But it was that, like, it wasn't actually running in the loop, the thing in the loop I thought that it was. And that's why it seemed fast. And so this is where I feel like having collaborators work on benchmarking with you to cross-check, whether it's pair programming or not. It's so low level, and as you saw, like, you're so in the weeds on these like command line tools. I feel like even when I was younger, I would get kind of lost a little bit in the sauce, because it is so tedious and low level. And so this is where having great collaborators to cross-check is really key, but also to make sure that you aren't intellectually cheating yourself because you want to get to the answer faster, which I feel is which is a trap some people can fall into sometimes.
So Matt, for the wrap up, maybe, so we showed that repository from a year ago. That one has benchmarks and instructions as well, how to run. The ones that we showed today, those are not included in that old repo, right? Maybe the benchmarks are, but like the new instructions are not. Is that correct?
Yeah, so the
Okay.
benchmark that's in that repo that we did have here today is that 3JS frustum culling reduction. So we had that today, but we couldn't run it because Hermes C was hanging
Okay.
on the host compiler. And so, but again, I just to be really super clear, Saban might be screaming, going like, "Why didn't you do that?" What, like there might be something really dumb I didn't do that would have fixed it or something like that. It may be completely my fault, and I want to be fully cognizant that this might be a Matt problem, not a Hermes problem in particular, maybe.
Yeah.
So that frustum culling benchmark is there in that repo. I just reduced it even more but while still capturing the workload so that I could get it into a 2 kilobytes, one line pastable thing to try to make it easier to get ADB to run it on the device instead of transferring a bunch of files to it. Or I want to avoid a bundling step with a bunch of Webpack crap in there. I was like, let's just get Webpack out of the way. It's just pure JS, more or less. One file that even when you format it, you can kind of read what it's sort of doing. So that benchmark is in there. These other benchmarks for CDJS, the collision detection one, and the JSON encoding one, we should absolutely be in that benchmark test app repo.
Okay.
I just don't quite have the again, like this is a service to the community that we're doing by doing this work unpaid. So after the live stream, my curiosity will and my commitment will end unless. But if someone wants to send PRs, absolutely. And I did do a bunch of work in that repo. I lost so much time tracking down why JavaScript core didn't work anymore. Because that community repo for JavaScript core that Oscar and all those people worked on wasn't released that long ago. So it must have worked then. And I spent a lot of time tracking that down, and I'm just kind of out of my time box of free work for the community that doesn't line up with with my company's immediate goals.
Yeah, understandable.
Yeah.
Right. So
I guess like we'll wrap up soon. So like maybe some last words.
Closing
Meaning
thoughts.
like what would be like the underlying message from all of this to people that want to know like how good is Hermes V1? Which one should I use? And probably it depends.
I wouldn't say it depends. I mean,
well, it depended to Matt, right? He has a very specific use case with large JSON files representing some kind of vectors in 3D space. You have 100,000 of those to parse and stringify. Hermes
that's true,
was
but
not the best solution on that one.
That's true,
and on the other part of the spectrum is that Expensify app that's mentioned in the blog post, where you just switch the engine and it's suddenly 10% faster with no work required. So like,
that was sorry. That's what I tried to say, that if you have to choose between Hermes and Hermes V1, use V1. Like this is this is basically no-brainer. Like it's better. It has more native features, so it'll be faster. 10% of gains in Expensify, of course. More to come with Babel transformations being turned off in next React Native, I guess, and Expo probably. When it comes to using like alternative VMs, then it comes and boils down to basically what's the use case you need alternative VM to. Like, do you struggle with performance and you know that this particular algorithm works good in JSC, for example? Because if you are to change VM like blindly to see if it works better, then probably it's not worth it, because you will spend so much time like putting multiple things together, fixing bugs in upstream repositories because they don't work for some reason, that in the end you will basically waste time, unless there will be all the fixes by Matt will be merged and it will be easy enough. Like you will need only 30 minutes to set up the whole thing and another 30 minutes to test it out.
Yeah. I think in terms of like the choice, I would love to be correct. I'd love to be incorrect in my I'd love to be incorrect in my perception on this, but it really seems like it's Hermes or nothing right now in React Native, and might stay that way. So there really isn't a choice for most people, because most people aren't going to dive in and do this crazy shit that I do, because it's just their audience for their app doesn't demand this level of detail orientation. It's not a bad thing. It's easier in some ways. I'm always playing on hard mode because I don't know how else to be, I guess. But like, but I think so. The question is, should people upgrade to React Native 82 or 83? Is just got the release candidate just got cut. So whatever.
As soon as possible, or not?
Yeah, exactly. Should they stay on the Hermes that they already have, versus upgrade to this V1 version? And I think it does depend on how much time do you have to spend to update your Metro config and your Webpack config and that other stuff to make sure it's using the new built-ins, not adding polyfills or using them unnecessarily, and that stuff. And to be clear, like I said, like being this detail oriented can be the difference between you've got 8, I don't know, bike sharing apps or whatever else. Which one feels the best when, especially with AI coding assistants and agentic coding stuff? It's good. Yeah, I think it's going to be that stuff where it goes like, this starts up faster, or this has a 120 FPS animation that doesn't stutter. And a good example of this is Duolingo. Like their animations are so smooth, and they also don't run your battery down. And someone had to get really detail oriented on the technical side to make that happen. And versus there's another app called Brilliant, which is kind of the same, but the animations are not nearly as smooth. Like it's still cool, and my daughter uses both of those apps. But I think this will be the differentiator when you've got, okay, now you've got 50 bike sharing apps. Which one wins? Or you've got 50 of these apps because people just like crank them out. And I think this is where it'd be a difference.
Still, we need to remember that sometimes we don't need to be faster. Like,
absolutely,
the app works totally fine. And we can, for example, spend 3 days of work just to bring down numbers by 10 milliseconds. People will not notice 10 milliseconds. So this is totally not worth it. So unless you have, like, your app is underperforming on, let's say, slow devices, then you don't need to be in a hurry, basically. You can wait. You can postpone the update for another month, 2, 3, 4, 5, 6, because you are not going to gain much from it. In contrary to the time you will spend on bringing React Native up and then enabling V1, which is a different thing.
Yeah, exactly. And this is where, like, we talked early at the beginning about some people would say, like, really old versions of React Native, they were fine. Like, they didn't have a reason to upgrade from React Native 0.39 to 0.55 or whatever. There was not a tentpole feature. Their app was deployed. It was working. You know, they had OTA deploys set up, so they didn't even really need to recompile their binary when a new Xcode came out or whatever else. And so, like, there's in these situations where I got really detail oriented about performance, and it might sound like that's all that I do, and that's like, it's like a small fraction of what I did at these various companies, but it's driven by a business imperative or a visionary product design, right? It didn't come from, it wasn't engineering driven. It was coming from product or the business in some fashion, where it's like, these are things we can do to enable the product design vision, or things that we can do to enable this business outcome, where it's like, hey, I don't know, the mobile app is performing really poorly, particularly on phones in the Philippines. Why? And then you dive into why, and you're trying to expand your business there, right? So I feel like if you've got a top level, kind of a higher level driver, so you know when to start and when to stop. Because with performance, you can just keep shaving that yak, right? It can be a never-ending sort of thing. But if like Expensify, shave however many milliseconds off interpage navigations and these kinds of things, and then you see an uplift in user engagement, which is what usually happens in my experience. Is you made the app start up 2 seconds faster on an HP laptop or whatever, but in my experience, that when you've got even low millions of daily active users, you get the data to see like, oh, engagement does go up depending on what the app is, and does it engender more engagement naturally or not. So that usually this stuff equates to not just a number going down or you feeling good about a specific number. It usually has some business outcome, like the doubling the frame rate of the Roblox application by porting React 17 into Lua that I talked about at React Universe last year. Same thing, where it was just like, if we make the app faster to start up by seconds on an iPhone 13, a high-end phone, never mind a low-end phone, even a high-end phone, or can we get the app to start up without crashing on Kindle Fire tablets that are really popular with kids and happen to have a low amount of RAM? Like, it's not just our performance telemetry says that the frame rate's better on that device. You see engagement go up and to the right, and that's usually the business. Boiling it down, usually the business people are in is not less engagement, but more engagement, usually, not always. And so if you're driven by a higher level goal, you can kind of know when to start optimizing and when to stop. And you're like, hey, this is good enough. Or that you don't even need to start, because you go like, hey, we don't care about iPhone 8. We only care about iPhone 11 above. And we know that the web GPU performance on it with the Node module, the Node native module is good enough for 60 FPS on that phone, for instance.
And Hermes V1 would be the best choice for like most applications out there, with the constraints that if you want to use other engines, you have to do quite a lot of legwork anyway to try to run them with React Native.
Right now it looks that way. Yeah. And so I would say that it's using the question is, do you upgrade React Native and get Hermes V1? It's not, do I use JSC?
Yeah.
I don't think most people that don't have an out of tree platform will bother to. It won't be a profitable endeavor for them because of just how low level the work is. Yeah. And they may not be staffed for it unless they engage someone like Callstack to do that system work for them.
We encourage you to do that. Just like read this neon that I have, hit us up. Let's wrap it up, guys. Thank you so much for joining me for me to learn and for you to teach me about the Hermes V1 and like what it takes to run different engines and how is it different from other engines and like in what benchmarks it might perform slower. I have this music that I always play when we thank people for joining. Thank you, Matt, for joining and for like preparing for this live stream. Thanks, Szymon, for helping me out as well. And I want to thank Ryan and Andrid and Bernardo and Łukasz and Svetan, of course, for being here and listening to us and engaging in the live stream. And also Mike for starting this company 10 years ago, working with Matt 10 years ago, and allowing us to do all of that right now. Thank you so much. We'll be back with the live stream next week on Thursday. Thank you.
Awesome. Thanks, guys.
Thank you. See ya.